ready for this story?
And here we test connection stress, performance, reliability.
When he lets me know that he has a server going, I'm going to go ahead and execute the stress right here. And this client will be hit with 60,000 connections.
SLAB 6, yeah, 2260 is SLAB 6.
This is Michael.
So what happened to the last home crew? I liked them better, they were nicer.
I'm Michael Likas. I work in the Build Lab. I'm one of more than 3,000 engineers creating Whistler, our next-generation operating system.
This is where the work gets done. Each of these windows corresponds to a different architecture. We boot test the binaries up above.
To keep such a huge project manageable, we've split the engineers into 6 teams, which work independently. They take turns submitting code to me in the Build Lab, and it goes through what we call the daily cycle, our method of producing and testing the OS. Farzana Rahman is a manager in the Network Services team, which is checking in code for a build today. She's letting the build team know that she's just sent us some new files. Then, she'll head over to War Room to see if there are any bugs that affect her.
Chester.
So, speak of the devil. We've been waiting for you to turn up.
If the Build Lab is the heart of the daily cycle, War Room is the brain. It's where we coordinate the engineering tasks, assign developers to fix bugs, check our test results, and plan to release the next build.
Let's try and get it to IDS. And if we've got to fix bugs, we'll fix bugs.
Michael, can you scroll down, please? 32-bit, we are looking good so far. We'll be done by the end of the day, so we'll be able to sign off on that one. Okay. 64-bit, like I said, we are trying to drive both of them, but we are blocked on the visual test. Okay. After the meeting, what we do is we type up an email and catch the right people, because I know who is responsible for knowing what is the status on a particular bug.
Once Farzana has dealt with the bug she got in War Room today, her development team is ready to send their code to the Build Lab.
So a lab gives me all of the changes that they've been making in their private branch. We compile that source code into binaries. We produce maybe 4,000 files. This process takes about 5 hours now. Now when I produce a build, I produce a personal version and a professional version, the server and advanced server versions, all at once because the source code is all the same. If we started at 9 a.m., we're already at 5 o'clock in the evening, and all we've done is booted the bits that we've tested. At the point that we finish all of our boot tests, leave the Build Lab and actually kick off the process to the BBT team. Their goals are opposite my goals. My goal is to push a build out. Their goal is to prevent a build from getting released by finding bugs. What bench is this, John?
This is the Whistler 32DS bench.
So 32-bit DS testing is all happening here, directory services.
We're currently waiting for a build to come in so we can begin our testing.
They're always waiting on us, and we're always waiting on them. So we should have a build for you really fast.
So while the testers are testing code generated by our lab, the developers are testing their own code before they check in. This is known as prefixing.
One of the tools we have is the prefix bug analyzer. You can run that tool on a lot of source code and highlight some of the problems that could surface. There may be some issues that could be quicker to find this way.
You got to figure out what went wrong.
I'm just trying to debug this machine.
Prefix is a tool that helps us do just that.
Once the boot test's complete back in the Build Lab, we post it to special servers and begin BVT testing. When the verification pass is finished, we designate the build TST. That's a signal for the development and test teams to download it and get to work. At this point, a wide variety of devices and hardware configurations are tested across the various labs. The stress teams dig in for the night.
This is the core plug-and-play test lab. These two guys, if you give them something to test, they can come back and tell you whether the fix is good. This is the main hot docking and hot plug devices testing portion of the lab. If we get to a point where they're not finding too many more bugs, then we usually start finding more hardware. This is what we call the USB card of death. This one cable that plugs into this hub here, in turn plugs all these devices on this entire cart into that one machine all at once.
These two benches right here are used for RAS stress testing. We have performance monitors going on it, and we have ways of tracking all of the calls that come in and things like that.
My team's goal is to make the machines break. About mid-afternoon, a new build gets released. We'll send out a note to the dev community, have them upgrade and run stress. It runs overnight. Some of the machines survive, some die. You know, there's no smoke, there's no blood, and then somebody from my team We'll come in at about 6 or 6:30 in the morning and start triaging those dead machines. And at about 8:30, we start putting together all our master reports. And then at 9:30, we go to the war room.
So it's back to the war room, where bugs get assigned again. The developers make fixes which are reverse integrated into the build. Our next developer team gets ready to submit for tomorrow's build. And today's build moves on to where the rubber hits the road in applications testing.
What we're really testing here is the end user experience, the customer experience.
It should print out like this on PostScript and PCL printer language. But on PCL it's printing out like this. The customer's not going to be happy if they get their printout looking like this.
Mail clients, remote control. Right now I'm doing a lot of corporate graphics programs.
I test database applications.
We improve the product on a daily basis.
When a build passes sufficiently in all our test labs, BBT, stress, and application compatibility, we send it to our burn lab and make CDs for about 500 of our closest friends and business partners. That way, they can see where we're going and let us know about bugs we may not have caught. They write back to us, we fix the bugs, and the cycle continues.